Hey folks, let's do a couple of review sheet problems. Let's start off with 3C. That's what I'm really itching to do. 3C. Has a little something we're not used to seeing, so let's take a look. We know that if we plug in 1 for this limit, that we're going to get 2 over 0. So we know that our limit's going to be infinite, and the question is, it's going to be positive infinity or negative infinity. But just take a note on this one. It's a little bit different because instead of x minus 1, it's 1 minus x. So stuff is a little bit backwards. There's not a whole lot of work to show, but just keep in mind that x is greater than 1, right? So that implies that, well, I guess it means that negative x is less than negative 1, right? Because when you have an inequality and you multiply it by negative 1, the inequalities switch. And that in turn implies that 1 minus x is less than 1 minus 1, which we know is 0. So that means that 1 minus x is less than 0. Okay? So this is actually negative infinity. Okay? That's the work that we would show for it, is right over here. Maybe we can even move this up here and shrink it a little bit. Now, you don't need to show this work. Maybe I'll put this in parentheses. All I need to see is this. Okay? But just be a little careful with that reasoning. All right? Maybe we'll do number 4 also. I'm just going to sketch it out. I'm not going to write all the sentences and stuff. For number 4, right, note that, well, you could say that negative 1 is less than or equal to sine squared is less than or equal to 1. Might be a little bit of a better inequality to say this, right, just because sine squared is never negative. But anyway, you multiply both sides by 1 over, or all three sides by 1 over x squared. You get that. And you can note that the limit as x approaches infinity of 1 over x squared equals 0, which, by the way, is that bound. So it equals, well, I guess I'll just point out that it equals the limit as x approaches infinity of 0. So by the squeeze theorem, we get that this limit also equals 0. Make sure to say by the squeeze theorem. I'm sketching it out. Maybe I'll just write okay, I'll be a little bit lazy. Not write a complete sentence, right? But again, all the structures there. Here, right, similar approach. You just multiply all three sides by x squared. Oh, no, I guess we're actually going to 0 in this case. All right, and so the squeeze theorem. Okay, so again, really rough sketch here, right? Okay. Maybe number 6, too. Yeah, let's just do number 6 to round it out, okay? Just remember, first off, you're going to want to let f of x equal x cubed minus 45x plus 2. So f is continuous. Make sure to mention that your function's continuous. Also, we can note that, I guess we can say f of 0, which equals 2, is greater than 0. And f of 1 is less than 0. So by the intermediate value theorem, there's some c such that f of c equals 0. And I suppose we want to be a little more specific. We can say there's some c within the interval 0 to 1. You don't need to say that, but it'd be good to say that. Okay? So the equation has a real root. Okay? Couple of problems, couple of solutions. Best of luck tomorrow.